Alright, so you've just seen how to solve a right triangle, finding the sides and the angles. But what happens when our triangle is not a right triangle? So for example, let's say we want to solve triangle ABC with the following measurements. Angle C is 103 degrees. Angle B is 28 degrees. And side B is a length of 26. Now we're not going to be able to use sine, cosine, and tangent like we could in a right triangle because this is not a right triangle. This right here tells us for sure that we are not dealing with a right triangle. So we need another tool, another trick for figuring out how to find angles and sides when we're dealing with triangles that are not right triangles. And for today, that trick is called the law of sines. And what the law of sines says is, in a triangle where we have angles A, B, and C, and we have corresponding sides of A, B, and C, it is always true that the ratio of the sine of an angle to its opposite side is equivalent in all cases. Okay? So I can set up a proportion using any two of these ratios, and that will create an equation that I can then solve for any missing part of it. So the law of sines works when I know some angle and the side opposite that angle. And then if I have one other piece of the triangle, I can set up a proportion that helps me find the missing piece. Okay, so this is what we're going to be using today, is the law of sines, where we're using these proportions to set, or excuse me, these ratios to set up proportions that will help us solve for the missing parts of the triangle. Okay, so back to our triangle here. I often recommend that you draw a quick triangle just to show what's going on. It doesn't have to be perfect. It doesn't even have to be to scale. It just gives you an idea of what measurements are where. And then label what we know. We know angle C is 103 degrees. We know angle B is a 28. And we know side B is a 26. I also highly recommend that you set up kind of a table for each of these, because we know in order to solve this triangle, we have to find the measurements of all three angles, which are our capital letters here, and all three sides, which are our lowercase letters here. So again, let's fill in the pieces we know. We know that we know that C was the 103 degrees. We know that B was 28 degrees. And we know that side B was a 26. All right, so what's the easiest thing that we can find first? Well, I hope you recognize that if I have two angles, B and C, then it's very easy to find angle A by simply subtracting my B angle and my C angle from 180. Because we know that all three angles of a triangle have to add up to 180. And so when we do that, we get 49, and that means angle A is going to be 49 degrees. Okay, so that was an easy missing piece to find. Now let's look at one of the sides. Let's start with side C. For side C, right here, we can use the law of sines because we already have an angle and a side that are across from each other. So this angle and this side being across from each other allows us to set up one ratio in which we already know the measurements. And then we can set up a second ratio using this angle in order to find this side. So our 103 here is opposite side C here, and so our second ratio is going to be the sine of 103 over our C value. And now we can solve for C. We should be able to take 26 times the sine of 103, right? Cross multiplying here with our proportion. Divide that by the sine of 28, and that will get us our C value. Okay, so now if you go to your graphing calculator, the first thing you want to do is to make sure that you are in degree mode. So we need to go to our home setting here, choose settings, which is number 5, and then choose document settings. And right here where it says angle is where you set the mode for your angle. Mine is already set in degrees, so I don't need to mess with anything. But if you had been in radians, then you would click this little arrow to the right, you would choose your degrees, and then you want to click on Make Default. Don't just click on OK, because it's not going to necessarily change the setting for everything. So we want to make this the default so that all of the problems we do now will use degrees as our angle measure. It's going to ask you if you want to save and all your settings. You say OK. And then if you already had something open, you could go back to current, or we can just open a new document. Make that a calculator, and we're ready to go. All right, so now we can take 26 times the sine, which is here under the trig button, the sine of 103, and then divide all of that. Whoops, I need to get out of my parentheses there. There we go. Divide all of that by the sine of 28. Now, when you hit enter, if your settings are for exact answers, what you're going to get for an answer is some version of what you started with here. Okay? And it's all in sines and cosines still, and you're going, what the heck? I want a decimal. Why is it giving me this? Well, it's because you have your calculator in exact mode. So all you have to do now to get the decimal is to hit Control Enter, and that's the blue symbol up here above the enter sign, which is the approximately equal to sign. So that will take this answer that you had from the previous line, and it will give it to you as a decimal. So if we round to the nearest tenth in these cases, that would mean the 6 would go to a 0, and this would be 54.0 as our answer. So our C ends up approximately equal to 54.0 degrees. And we can fill in that spot. Okay, finally, we need to find side A. And we're going to do the same thing that we did with side C. we're going to use the sine of 28 over 26 as my first ratio, because that's measurements that I know right here with 28 and 26. And then I'm going to take the sine of 49 over A, because 49 now is the A angle that's opposite the A side. Okay, so again, that means taking 26 times the sine of 49, dividing all of that by the sine of 28. That should get me my A. So if we go back to the calculator, I need 26 times the sine. You can also just type SIN and see how it went from italics to non-italics when I do SIN. That's because this is a function that is already programmed into your calculator. But then you have to put your own parentheses for whatever it is you want to put in it. If you go here and get your sine in the trig menu, the parentheses will automatically come up with it. Okay, but if you just want to type SIN, you can do that, but then you'll need parentheses around whatever you're taking sine of. So in this case, it's the sine of 49. Get outside of my parentheses and divide by the sine of 28. And now, because I know I want a decimal answer, I'm going to automatically do a control enter so I get the decimal answer right away. And my decimal answer ends up being a 41.8 when I round it to the nearest tenth. So 41.8 degrees is what we fill in here. And now I have solved my triangle. I have all three angles and all three sides worked out with the correct measurements. Oh, but I did make one mistake here, didn't I? These aren't degrees, these are sides. So we don't need the degree signs on there. These are side measurements. There we go. The numbers are still correct. We just don't need the degree measures on there. Okay? So we've got all three angles, we've got all three sides, we have solved triangle ABC. All right, let's try one more. And this time I want you to try it first. See if you can solve it yourself using the law of sines. And then we'll come back and we'll walk through it together. All right, so let's solve triangle ABC with the following measurements. Angle A is going to be 55 degrees. Angle C is going to equal 82 degrees. And side A will be 8. Take a moment and pause the video if you need to. Solve the triangle with these measurements, and then come back to check your answer. All right, so if I do a quick triangle here, label my vertices with A, B, and C. Angle A is 55. Angle C is 82. Side A is 8. I'm also going to set up my little framework here, my table, so that I can fill in the three angles and the three sides as we find them. So first I'll fill in the ones we know. 55 degrees, 82 degrees, and 8. All right, so again, the first thing that's to find, that is the easiest to find, is our third angle. And so angle B will be the result of taking 180 minus 55 minus 82, and that's going to give us an angle of 43 degrees. And this is an angle, so this is a degree measure. Okay. Secondly, we can find one of our sides. So if we decide to find B first, then that means we want the sine of 55 over 8 for our first ratio, and that's going to be equal to the sine of 43 over b. So that means we're going to be taking 8 times the sine of 43 and dividing it by the sine of 55. That will give us our b value. So come over here to our calculator, take 8 times the sine of 43 and divide that by, our sine of 55. Do the control enter so that we get the decimal, and we get 6.7 as a rounding to the tenths. So 6.7, 6.7. Okay, and then we can use the same setup for side C. We'll have the sine of 55 over 8, and that will be equal to the sine of 82 over C. So that means taking 8 times the sine of 82, dividing that by the sine of 55 to get our C. Back to our calculator, 8 times the sine of 82 divided by the sine of 55. Control enter. We get a 9.7 approximately. So 9.7 when rounded to the nearest tenths will be our measurement for C. Okay, so those are the kinds of problems you're going to be doing on the 3.1a practice. You can also use these for application kinds of problems. If you look at the application that's on your notes sheet, we're told that a 123-foot wire for a transmitting tower makes a 61-degree angle with the ground. This wire is to be replaced by a new wire whose angle with the ground is 46. How long will the new wire be? So especially with applications, if there isn't a diagram already given to you, you definitely want to draw one. So here's our ground. Here's the transmitting tower. Currently, there is a wire that runs from the top to the bottom, makes a 61-degree angle with the ground, and is 123 feet long. Okay, now if the new wire is going to make a 46-degree angle with the ground, do you imagine that it will be closer to the tower or farther away from the tower? I think you can tell it's going to be farther away from the tower. So let's do this in a different color. This is going to be the new one. Okay, and this is going to be a 46-degree angle that it makes. Now, we could go through several steps saying, well, this is a right triangle. I have the black right triangle here. I have the other right triangle that this green one makes, and go through several steps trying to use the right triangle. But that's not really necessary because we can also just work with this triangle that's being made by the new wire and where the current wire is. Now what we have to do though is we have to figure out this angle right here, because what we know is this one. but I hope you remember that a straight line makes a 180 degree angle. So if I subtract the 180 or the 61 from 180, then we're going to get a 119 degree angle. Okay? And so what I'm trying to find then is this. Now in this case, we don't necessarily have to solve the entire triangle. We just have to solve enough of it to find the missing piece. So we now have a situation where I have a 46 degree angle across from a side that's 123. So I know that the sine of 46 over 123 gives me a ratio that has to be true for all angles and sides. And then I now know that I have this 119 degree angle here, which is across from the side that I'm wondering about. So that means the sine of the 119 degree angle has to set up a ratio with my missing side, and that's what I need to solve. So I don't have to solve for everything in this problem, I just have to solve for the missing piece. So that means taking 123 times the sine of 119 degrees and dividing that by the sine of 46 degrees in order to get my missing side. So back to our calculator, 123 times the sine of 119 divided by the sine of 46. Control Enter to get a decimal answer, and we get an answer of 149.55, so we can round that to about 150. Okay, so we would expect that the new wire will be about 150 feet. Okay, and again, we're just using the law of sines as the way to set up a problem like that. So, in your homework, you'll be doing some problems like our first two, where you're just given 3 of the measurements of a triangle and you need to find the other 3. And then you have a few problems where you're using the law of sines in application situations to see if you can find the missing piece to answer the question. Okay, so give it a try. Take a look at your 3.1a practice. If you have any questions, please make sure that you get them answered by me or by someone else who can help you. And we will see you next lesson.